All right, welcome to Living Room Floor Chemistry. So we're going to talk about structural formulas a little bit today and how to write condensed structural formulas. So when I have a molecule like this is butane, it's got 4 carbons in a row. How I look or think about this condensed structural formula is based on what's happening with each carbon. So I'm going to break this up into the groups around the carbon. And then what I'm going to do from there is I'm going to look, I have a carbon with 3 hydrogens on it, so I'm going to have a CH3. Then next to that, I have another carbon with 2 hydrogens on it, 1, 2. I have another carbon with 2 hydrogens on it. And then I have another carbon with a CH3 on it. So that's how I would write the condensed structural formula for this one. Things get a little bit hairy when other different things come into play. So for example, this one's isobutane or 2-methylpropane. It has this first carbon group, but then it has this carbon group with this thing attached to it down here. And we're going to talk about what we do in this situation. So what we want to do is we want to find our main chain, 1, 2, 3. Here on the first carbon, I have a carbon with 3 hydrogen groups, so CH3. On this carbon, I have 1 hydrogen directly attached to it, but I also, and I'm going to use a bracket here to show that it's also a group attached to this carbon as well as that hydrogen. I have another CH3 group attached to it. Then to this carbon, I have another CH3. Sometimes you may see it written as this. Because I have 2 of them. It just means that off of that carbon, I have 2 CH3 groups. When you have things like alkenes, alkanes, alkynes, it's important that we just write the number of hydrogens attached to that carbon. So here, the first one's a CH2, then I have a CH, then I have a CH3. And that tells me that there's a double bond if I was to look at this, because if there's only 2 hydrogens on this terminal carbon, I know that there has to be a double bond. Normally, if this was an alkane, there would be 2 hydrogens here, but there's only 1. So it tells me by the hydrogens that are not there, whether or not I've got a double bond or a triple bond, etc. If I had, say, a triple bond here, it would be like this. And I would do the condensed formula as carbon with 1 hydrogen, then a carbon, then a CH3. And that tells me how that works. So hopefully that answers the questions a little bit more about structural formulas and how to condense them.